Hello and welcome to Rat Lab. Today we are going to be learning about levers. We are going to find out about what they are, how they work, and how levers in our body help us to move. The lever is one of the most basic forms of machines. It helps us to lift loads with less effort. We can find levers around our house, such as many tools, but they are also found in the human body. Okay, so now let's go and find out what a lever is. A simple lever could be a solid beam called a lever arm laid across a pivot. There is also a load and an effort force. If we were to push down and provide some effort at one end, this would have the effect of lifting our load at the other end. The rigid lever arm would rotate about the pivot. There are different types of levers depending on where the pivot is positioned. We can have the pivot in the middle, like a seesaw, and the effort force and load on either side. We could also move the pivot to the end and have the effort force at the other end. This would be like a wheelbarrow, where the load is in the wheelbarrow, and that is what we are trying to move, and we are applying an effort force at the handles. The wheel acts as the pivot. Lastly, we could have the load at the end, like when we use a spade to dig a hole. The position of the pivot, load and effort force can change, but these are still all levers because they have the effort force, the load, the pivot and the lever arm all working together. In engineering, we can simplify the muscles, joints and bones to pivots, lever arms and forces. The pivot in our arm is our elbow joint. The lever arm is the bone. It is rigid, just like in our other examples. If you don't know what rigid means, it means that something isn't easy to bend. We also have forces. So if this person is holding something like a brick in their hand, this provides a force downwards, and we call this the load. Then we have the effort force, and this is provided by the muscles in our arms. It provides a force upwards so that our arm stays where it is. Let's find out more about how levers work. Let's imagine we were at the circus and they were trying to do a trick with elephants on a seesaw. There is an elephant on each end, and they are the same weight, and they are the same distance apart from the middle pivot. So that means that the seesaw is balanced. If we were to take one elephant away, the other one would just fall straight to the ground. Placing an elephant either side of the pivot creates a turning force in a different direction. Adding an elephant to the left creates a turning force anti-clockwise, and adding an elephant to the right creates a turning force clockwise. So, having an elephant either side at equal distance from the pivot makes the seesaw balanced again. The turning force on one side would get smaller if we move the elephant closer to the pivot, or if we made the elephant smaller. Because the turning force on one side has got smaller, this means the elephant on the other side will fall straight to the bottom. We can exactly half the turning force by halving the elephant, or we could have a whole elephant and move it halfway. To balance the seesaw back out, we would need to add another elephant to make the turning forces either side equal again. Our arm works like this. Our muscle is like the strong bodybuilder pushing up the elephant. The elephant is the load we are holding in our hand. Like the brick, the force acts down. If we moved the bodybuilder further away from the pivot, the bodybuilder would have a greater turning force, so wouldn't need to be so strong. If the bodybuilder was close to the pivot, the bodybuilder would need to be strong and provide a big force. So our muscles in our body are really strong because they are close to our joints. They are like the bodybuilder, they are close to the pivot, so need to provide a big force. So remember, in our bodies, bones act as lever arms, joints act as pivots, and muscles provide the effort forces to move loads. Let's finish with a quick quiz. Which one of these is an example of a lever? A pencil, a wheelbarrow, or a table? If you chose wheelbarrow, well done, that was the right answer. Which two of these affect how large the turning force is? Is it the distance of the object from the pivot, the roughness of the object, the shape of the object, or the mass of the object? Remember, it's two of these. If you chose options 1 and option 4, well done, that's the right answer. Okay, and finally, our last question. Which two of these diagrams would lead to a balanced seesaw? Have a look at the diagrams and two options are correct. If you chose option 2 and 4, well done, that's the right answer. Well done, that's great. Now, have a go at the fun activities with your friends and family. Once you've completed the activity, watch the next video for an explanation on how the activity works.